Okay, we're going to continue our triangle journey with congruent triangles. Congruent means they have the same size and same shape. So we need to talk about corresponding parts, and you might be familiar with that from the corresponding angles. Of our corresponding angles, those were about location, location, location. They were in the same position of the parallel line and transversal. So these corresponding parts in congruent triangles, they're going to be in the same location within the triangle. So a triangle has 6 corresponding parts. It has the 3 sides and the 3 angles. So 6 parts total, the 3 sides and the 3 angles. When we have triangle ABC is congruent to, that symbol here is the congruent symbol. An equal sign with the squiggle over, triangle DEF. This is what's called a congruency statement. They're actually telling you what the parts are that are corresponding. And yes, order matters. The order that these come in matter because that establishes the correspondence. So if I have triangle ABC, and I underlined A in red, B in blue, C in black, and again that's color coding to help with the corresponding parts. And I underlined D in red, that's because they're both the first letters, they correspond. E is blue, it's in the middle, it corresponds to B in the middle. And F is black, it's the last letter, it corresponds to the last letter C. So this congruency statement tells you what the correspondence is. So since we have 3 sides and 3 angles, if I go with my angles and I'm color coding them, the first one is A. That corresponds to the first letter D. So angle A is congruent to angle D. Those are corresponding. Angle B is congruent to angle E. So I have both the middle ones. They're corresponding, which means they're congruent. And then I have angle C is congruent to angle F. They're both the last letters. They correspond, they're congruent. Then we get to the sides. So I have AB, that's the first 2 letters. It's going to correspond to the first 2 letters of the second triangle, DE. So AB is congruent to DE. BC is congruent to EF. That's the second and third point, second and third point. They correspond. They make that side. And then I have AC is congruent to DF. And you can see the colors correspond to one another and the points correspond where they are in the congruency statement. Okay, so those congruency statements are there to help, and they establish that corresponding part. Okay, so then we're going to get into our congruent triangle theorems. Okay, so to prove triangles are congruent, you would have to prove all 6 parts were congruent. So you would have to show me all 3 sets of angles were congruent. All 3 sets of sides were congruent. Okay, that's a lot. That's 6 things that you would have to tell me. Now, with the postulates, they narrow them down to just 3. If you get these 3 components, corresponding sides or angles congruent, then I can prove the triangles are congruent without having to do the other 3. So here we have side, side, side postulate. SSS stands for side, side, side. So here's our logical statement. If 3 sides of one triangle are congruent to 3 sides that correspond on another triangle, then the triangles are congruent. So instead of having all 3 angles and all 3 sides, I can just show that all 3 sides are congruent that correspond to one another. Okay, so that's the side, side, side postulate. Okay, well here's another one. Side, angle, side theorem. Side, angle, side theorem. If 2 sides and the included angle, that means the angle in between the two sides, of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So that actually comes in that order, side, angle, side. Okay, so that would help, and I only have to have 3 of the parts. I have to have a side, an angle, and a side instead of all 3 sides and all 3 angles. So if we take a look at this example, I have triangle ABC and triangle EFG, and I want to determine whether or not they're congruent. So these markings that you see here, these hash marks, those indicate congruency, and we've talked about those before. So AB is congruent to EF, which makes them corresponding. So AB matches up with EF. I have angle E and angle A marked the same. That means they're congruent and they correspond to one another. And then I have AC congruent to EG. Those are congruent and they're corresponding. But if I look at it a little closer, what do I have here? I have a side, an angle, and a side. Let me come back over here to EFG. I have a side, an angle, and a side. That means that these two triangles are congruent, and I have that side, angle, side theorem. That side, angle, side theorem. And that's why this example would be congruent. Okay, so over here it says given EG is the angle bisector of DEF. Okay, well here's angle DEF and EG is the angle bisector. We constructed these. We know the angle bisector means that it's splitting the angle into 2 equal angles. Okay, well I see I have an isosceles triangle here because DE and EF are congruent, and that EG splits that into 2 smaller triangles. And one of the things I notice is that the 2 smaller triangles share that side. Well, I can mark that side. I can mark that side congruent. It's what we call reflexive. It's the same side in both triangles. It's like you're looking in a mirror and you're seeing a reflection. So this is a reflexive property, and I can mark it as being congruent. So if I look at the pieces now, let's see, I have DE and I have angle DEG, so there's an angle, and now I have that EG side. So there I have a side angle side on this triangle. Let's see if I have side angle side on the other triangle. So here I have the corresponding side. Here's my angle, and then they have that same side. So these 2 triangles are congruent by side angle side. And I've proven that. I was given enough information about the angle bisector to know I had 2 congruent angles. And then I have my reflexive property, which is kind of like a reflection. You're looking at yourself in a mirror. And I can state that congruency, that EG is congruent to EG because they're the same side in both triangles. Okay, so then on my last example here, I'm given NP is congruent to RQ. So they didn't mark it on my drawing, but I can. NP, okay, so there's a mark, is congruent to RQ. There's my mark. Okay, and then NR, and I'm going to mark it differently because it's a different congruency statement, is congruent to PQ. Okay, well I have corresponding sides with NP and RQ, and I have corresponding sides with NR and PQ. So one of the things I noticed too is NQ. They share that side. So again, just like in the last example, I can mark that congruent, and I can state NQ is congruent to NQ. And my reason for that, remember everything has to be justified, is that reflexive property. That reflexive property. Okay, so that's my justification. I'm telling you these three sides are congruent. And now that I see that all three sides are congruent and corresponding, then these triangles are congruent by side, side, side. My green is not working out. So these are congruent by side, side, side. Okay. So then we have angle, side, angle. If two angles and the included side, which means the side in between the two angles, of one triangle is congruent to the corresponding parts of another triangle, then the triangles are congruent. So angle, side, angle in that order. Then we have angle, angle, side theorem. If two angles and the non-included side of one triangle is congruent to the corresponding parts of another triangle, then the triangles are congruent. Okay, so then I could have an angle, and then a side, and that would be included as long as that non-included side is corresponding. It's got to be across from the same angle in both triangles. Okay, and this would be a good time to pause if you need more time to write these down. Okay, and then our last theorem here is the hypotenuse leg theorem, HL, and this occurs in a right triangle. So this has to be specific to a right triangle. If two right triangles have a hypotenuse and a corresponding leg congruent, then the angles are congruent. Okay, so we have to have the hypotenuse, which is the one across the 90-degree angle, and a corresponding leg, so it has to be the same leg in both triangles. Then the triangles are congruent. Because remember, they're already going to have that right angle. So they've got that right angle. Then we're talking about the hypotenuse. And then we're talking about a corresponding leg. Okay, so if you have those pieces, that's the hypotenuse leg theorem. Some things to remember and some things that they will never, ever, ever mark for you. Things that you are going to have to do for yourself is, one, you're going to have to mark those reflexive sides. Those are the sides the triangles share, like here in this example. So if they share a side, that's the reflexive property, and you're going to have to make that statement and mark it. The other one that they're not going to tell you about is the vertical angles, because we've learned vertical angles way back a few units ago. So anytime you see the triangles crisscross each other, you have those vertical angles, and you're going to have to mark those as congruent as well. Okay, so I'm going to stop this video here. I have 2 more slides, so there will be a part 2.